So, hello guys. Today's presentation is about rotation about pivot points. So, as you know, have you ever noticed how a door swings around its hinge or how a pendulum moves back and forth? Why do they all have in common? They all rotate around a fixed point known as a pivot. Today, we will explore the fascinating world of rotation about a pivot point. So, topics to be covered are definition of rotation, pivot point, concept and its importance, mathematical formulation with detailed examples with diagram and calculations, applications in real life, and summary of key points. So our objective of this topic is understand the concept of rotation about a pivot point and its significance in physics and engineering. Learn the mathematical representation of rotation, including angular displacement, velocity, and acceleration, and apply the concept using practical examples involving levers, pendulums, and rotating objects. So we will also learn that how we'll analyze real-world applications of rotational motion to understand its practical. So definition of rotation is the movement of an object around a fixed point or axis. The fixed point is called the pivot point. What is the importance of the rotation? Understanding the rotation helps us design and analyze everything from simple doors and levers to complex robotic arms and mechanical systems. Introduction to pivot point. A pivot point is a fixed point around which an object rotates. The distance from the pivot point to any point of the object remains constant during the rotations. So let us discuss this topic in detail. So definition of pivot point is a pivot point is a stationary point around which an object rotates. Example includes the hinge of door, the axis of wheels, and the fulcrum of a lever. The key thing to remember the pivot point remains fixed while the object rotates around it. So the characteristics of the pivot points are fixed point, center of rotation, and that it determines the radius of the rotation. So it is the one example of the pivot point that rotating door hinges. So you can see in diagram how a door rotates around its hinge while. So let us discuss this topic in detail. Now let's get a bit technical to quantify rotation. We use a simple formula theta is equals to S divided by R. S is the arc length and R is a radius. Units can be written in the radians and the degrees. Where theta is the angle of rotation as the arc length and R is the radius. So for example, if a lever arm rotates through a distance of a 5 centimeter with a pivot radius of 2 centimeter, the angle of rotation is calculated as 2.5 radians. Let us take another example, rotation of a lever arm. Let's apply this to a practical scenario of lever arm. If the lever arm is 1 meter long and a force of 10 Newton is applied at one end, we can calculate the angular displacement using the rotational formula. This helps us understand how force is cause rotation in mechanical system. So understanding the pendulum motions. Another common example is a pendulum. As it swings back and forth around the pivot point, its angular velocity and acceleration constantly change. By analyzing the length and the mass of the pendulum, we can calculate the angular velocity at different points in the in its swing. We can also derive the angular velocity of its by the given formula. So it is the diagram of a swinging pendulum as we discussed earlier. So we can summarize this topic in 3 points: definition and characteristics of 5 points, mathematical representation of rotation, practical application in mechanical system. What is the importance of understanding the rotation? Crucial for engineering, robotics, and mechanical design. Applications in real world scenarios. But how does this apply to real world? Understanding the rotation about 5 point is crucial in engineering, robotics, and mechanics. From simple doors and levers to complex robotic systems, the principle remains the same. We can take the examples like levers and the pendulums, wheels, doors, etc. What is the conclusion of this? To wrap up, we covered the basic of the rotation. The concept of the rotation about the biofield is fundamental in physics and engineering, playing crucial role in understanding mechanical system. The conclusion is we explored the mathematical formulations, practical examples, and real-world application, highlighting the importance of mastering rotational dynamics. Understanding these principles aids in analyzing system involving rotational motion from simple levels to complex motion. Environment. Before we conclude, a special thanks to Mr. Shivsankar Rajput sir for his invaluable guidance to and all those who contributed to this presentation. Thank you.